Hi, I'm Micaiah, co-founder of Txtx, and one of our goals is to bring the security, reliability, and efficiency of Web 2 deployments through tools like Terraform to Web 3. And one of the ways we're doing that is with Solana program runbooks. These will allow you to deploy programs and operate on them, invoking the instructions that you've defined in your programs very easily. And so today I'm going to demonstrate deploying a program and calling it via Txtx. So let's go here to our runbook. I'm defining this signer, a secret key signer who's going to sign our transactions, and I'm naming it deployer. And then I've got a variable that I'm defining called program, and this is just going to get a program from our anchor project here. So it's going to get it by name. Hello World is the name of the program, and we can see in our programs we have this Hello World program. Then we have this action. We're going to name it deploy, and it's going to deploy our program, and we can just reference the program we want to deploy and the signers to sign the transactions. And then finally, we can reference the outputs of this deployment, such as displaying the signature here. So we have this runbook called deploy, so I can do txtx run deploy. I can pass in the -u flag here, and that's going to run it in an unsupervised mode. So it's just going to execute the runbook. Let me run it here. We see the transactions being, so we've got program data written to buffer, program created, and we have the output signatures of this creation. And then we could, if we can run this again, and we'll see that latest snapshot in sync with latest runbook updates. So Txtx manages the state of all of our deployments for you, so it will detect if there are actual changes that need to be re-executed. So for example, if we change the name of our Hello World function to greet instead of hello, and then we run an anchor build, and then we try and redeploy here, now we will get this diff, and we can see, okay, the hello function changed to greet, and this is the actual compiled discriminator that is in the IDL. And so we can decide, do we want to deploy yes or no? Next, we can look at calling a program. So this time we're going to do this in a supervised mode, which means it's going to be in the web UI. We have a web wallet defined where we can say what address we expect to connect to the wallet. We can once again, we're going to get the program from an anchor project. This time we will create variables that are editable in the web UI for the instruction we want to invoke and the arguments we want to pass to it. And then we can set up our instruction. So we say that the signer is here. Here's the one that we defined earlier, and the accounts that are part of this instruction, as well as the data, we can get directly from this program's IDL, where we can kind of verify the data, so we can pass in the instruction and the arguments and have type checking against the IDL. And once again, we can output the signature here. So this runbook is called call. So I can say txtx run call, and I'm not going to pass -u, so it's going to go into our web UI. If we go here, so we can see the expected address. We can connect the wallet, do phantom. Oh, this phantom needs to log in here. Okay, and we've got to provide the public key and check that we have the appropriate balance to do this call. Now we can start our runbook, so we can see the program that we're calling. We can see the instruction we want to invoke, as well as the arguments we're going to pass to it. We can validate all of that, and then we can actually sign the transaction. This is running on a dev net, so Phantom can't actually simulate the transaction, so it'll take a minute here, and then it will say it's not going to work, but we can confirm anyways. And we've got a signature, and we've got that deployed to the network.